Sweet. So I'll go ahead and show you how to process all of this data that we've just ran on Icon. So yeah, the plan for mine is to show the batch processing um, of the fractions, or you could batch process any other set of data, 1D data that you've collected using this method. And then I'll show you how to make visualizations of these in MATLAB, or you could also do it in MNOVA as well. So let me share my screen here. Okay, so what we'll be doing is in NMR Box, and this is the home screen that you see when you first log into NMR Box, okay? And the data that we will be processing today is in the events folder on NMR Box. So to open your folder, you can just click this button down here, and we're gonna go to Open Folder. And then also, is my text too small, or is it easy to see?
If you can make it a little bit bigger, that'd be great. But
Okay. And this is another useful tip for NMR Box. You can change the resolution of your screen to make it bigger and smaller. If you click this little bunny up here, you can go to Resolution Changer, and let me make it a little bit larger there. Okay,
yeah, that's great. Thanks, Chris.
cool. So let me reopen this folder. So you go to here and then Open Folder, and the data will be in Events in 2024 NAN Metabolomics Workshop in day 4, and the fraction library materials, and the data will be located in the data directory here. Okay. And I have 2 folders. I have ones that are not processed, and then I have ones that are processed, so we don't have to wait for it to get processed to show the pass. So let me go into the not processed to show you how to do the processing. So say, you run an icon experiment over a weekend, or you get an icon run going over the weekend. So this is what I normally do is I just take 140 samples and I get something set up on Friday and I run it over the weekend. I just check in every maybe 8 hours or something like that to make sure everything's good. And, it's little user intervention. You can just get all of these run quickly. And so after you go to the NAN portal that Mark Majeski talked about a little bit on Monday, you can download all of these directories here and get them into NMR Box where you can analyze them. So this is what you'd see, 140 fractions. And if I open one up, this is the normal directory that you see from a NMR collected experiment of a 1D. And the actual data here is this FID file here, this free induction decay. And this would take a really long time to manually process 140 fractions one by one, and would be kind of annoying. So Frank Delaglio wrote this really nice NMR pipe batch processing script that I'll show you guys how to use right now. So the first input to this NMR pipe processing script is this meta.tab file. And so you will have to manually, you would have to manually go in and give it the name of the directory, the index of what you want this file to be called, the title that you want it to be named, and the type of phasing that you want to do. So we can do auto phasing or first order phasing here. I wrote a script so that you don't have to manually type this in 140 times. So to access this script, which is called meta.test, I'm going to open a terminal and I'm going to make this folder my working directory. So in this folder, I can right click here and I can say open terminal here. Okay, and so now this terminal, my working directory is this folder that we're in right here. And to run meta.test, let me make this bigger so we can see. You do /, which just means tells the computer, okay, look into this folder that I'm currently in and let me run meta.test. Okay, then I'm going to hit enter. And since this is cotton data, I'm just going to name everything the same title, but the index will increase for every single fraction. So I'm going to name this cotton workshop. And I hit enter. Okay, and now our metadata file for the batch processing is created, and I'd always recommend to double check to make sure it looks good. Okay, and now we have it here where we have the index, the directory that it's going to look for to process, the title we gave it, and then we changed everything that the first order or the zero order phasing is auto phasing in NMR pipe, and the first order is zero. So after this runs, the auto phasing does a really good job most of the time. But say you have, something's going wrong, you could definitely go back. For a specific sample, you might have to go back and change this to a specific manual phasing setting that you want. For example, you could change it to like a 90 or something like that. But usually the auto phasing does a really good job. And so I'll scroll through to just make sure everything looks good. And what I can see, it looks pretty good. Okay. So now that's made. Let's check just, you don't need to check it usually. You can just leave it how it is. But the script that we're going to run to do the batch processing is called all.com. And let me mention too, so say you have this data directory that you downloaded off of NAN, you will need to copy and paste all of these files that I have in this events folder into that directory that you want to process. And so you can, these are here, these will be in your events folder for however long NMR box is up. So you can always just copy and paste from here into that directory. The only thing that you'll see when you get it from NAN are these folders here. Okay. So let me open up the all.com script that Frank wrote that we will be using to do the batch processing. And let me get this a little bit smaller. Okay. So the only thing that you would need to change here for your specific experiment would be this referencing script right here. So since this was run in DMSO, the position of the internal standard was a little different. It wasn't exactly at 0.0 when I was doing the processing. So I was just telling the script that the internal standard is showing up at around 1.5 ppm, and I want to make that chemical shift 0 for that internal standard. And so that's what the referencing it does. For DMSO, for example, my internal standard was TMS, and we're going to make that peak 0. Okay, and I'll show you that after it's been processed. Okay. So after that, all we need to do is open a terminal here again and do / and run all.com and hit enter. And the batch processing will begin. And this will take probably around, for 140 samples, probably around like an hour and a half to do. So let me do a little Julia Child here, and let me show you the processed spectra after it's been batch processed. So if we go back into fractions processed, we notice that we'll have 3 new directories that we've made. We have an FID directory, and this is just each one of the fractions before it's been Fourier transformed, and it's in NMR pipe format. We have an FT folder here, and this is Fourier transformed and processed data. And then the folder that I always use is the interp folder. And this just means it's just processed data, but it's always but it's also interpolated. So what I mean by this is, say that you have one sample that was collected with 64K points and another sample that was collected with 32K points. The interpolation that Frank has here will be that they will be the same number of points when you want to export it into like MATLAB or some other statistical software. So it makes it easy to process that way. Okay, and so that's the batch processing. Do you have any? Does anyone have any questions before I go on for visualization or anything like that? Yeah, TJ.
Chris, do you always add something for a reference to every metabolomic sample?
Yeah, most of the time we will have a reference for pretty much every metabolomic sample, but you don't have to have one in there. And if you want to get rid of that referencing script, all you need to do is go to the all.com, and you can just comment this out by just a $, and it will skip the referencing.
Thanks.
Cool. Yeah.
TJ, just for clarification, the reference that Chris is talking about is a chemical shift reference for, we usually use DSS. In this case with DMSO, it's I think it's TMS or Is it TMS, Chris?
Yeah, TMS.
Oh, something that we would use to put to calibrate the chemical shift axis.
Yeah. And so, yeah, like I said, in that all.com, it will look for that peak for this instance in between 1.6 and 1.4. But if you run something in D2O and use DSS as your internal standard, you can probably keep this at around like 0.1 ppm and negative 0.1 ppm. It's already usually around 0, and it will keep it right there. Okay, cool. So in this insert folder, you'll notice that you have a lot of .ft1 files here, and you can do a few different things to visualize. You can just take that folder. Let me open this back up. Excuse me. You can just take that folder and you can open up the application MNova, which is just another data visualization software, and you can drag this folder directly in there, and it will read it in so you can view every single thing one by one. So you can drag it in like this. And so let me show you what that looks like, just really briefly. So I have two MNova files that I've already dragged this in, and we're going to look at just the raw FT1s here. This other file is data after I've sanded these fractions. Okay, so I'm going to drag it in. It'll take just a second to load, and you can see every single fraction one by one here. And let me get the aspect ratio better. Okay. And then MNova has this nice option where you can stack these samples so you can view them like this. Okay. And you'll notice here, this isn't actually the best fractionation. This was an earlier sample, but it's a good demo sample. We have better fractionations that we're still analyzing more on, but we're just not presenting here now. But this is an easy way to visualize it here. Okay. Another way to visualize that I like is to do kind of like a 3D visualization, so you can better see how peaks are rising and falling. And plus you can do downstream analysis in here as well. And I'm going to show you how to do this in MATLAB. So I'm going to go to MATLAB -- container, and this will open MATLAB here on NMR box. Let me kill this previous thing before it goes. So I'm just get Control C. Okay, so we have MATLAB -- container, and I'm going to hit enter, and MATLAB will open up. Okay. Okay. So I have two MATLAB scripts in the events folder that we will use for demonstration here. I have one that's an earlier version. Oh, and sometimes on NMR box, MATLAB will crash, but usually it's been pretty good. Let me get this back up.
Hey, Chris, while it opens up,
Yes.
You mentioned that sometimes we might have to fix the phasing.
Yes.
So do you go into NMR pipe and look at like the first spectrum and then change the batch processing file, the metadata?
Yeah, I would visualize. You could visualize an NMR pipe, or I would first probably visualize an MNova just to get a broad view and see if like, oh, this one's way out of whack. And then I would actually do the phasing in NMR pipe. So to do that, you can just open up NMR draw. So let me go just a quick demo here. I go back to events here, and let me go to this enter folder. Okay, I'm going to make this my working directory again, and I can just type the command NMR draw like this. Okay, and so this is like the first spectrum, for example. And if I wanted to, like, say this wasn't phased well, I could change this on, and I could see what the phasing that we need by using these sliders here, so that the phasing is good. And then you would just input into that meta.tab file the phasing that you want that's here, located here. Does that make sense?
Yeah, thanks.
Cool. Okay. So now that MATLAB is back up, let me show you all the script that we're going to use. So I can go to, if you go to your home, let me X out of here. Let's go to your home here. I'm going to hit open, and I'm going to hit open here. And I'm again going to go to the events folder. So I'm going to go to events, the 2024 NAN Metabolomics Workshop, day 4, fraction library materials, and then I'm going to go to scripts. Okay. And I'm going to click on this visualize fractions 3D version 2. I'm going to hit open. Okay. And now we have this MATLAB live script that to demonstrate. So the steps in this script are first going to tell MATLAB the functions that it needs to use. We're going to import the NMR data that we just processed into here. We're going to visualize it after we put it into kind of a matrix format, which we can, so that we can easily manipulate it. And then I'm going to explain and show what Stoxy is. And this is the main method that I use to database match and annotate these fraction libraries. Okay. So there's 2 things that we'll need to do before we get started, and we can just run through this. We need to provide 2 paths to the script. So I'm going to open up my folder again. I'm going to go to events, 2024 NAN Metabolomics Workshop, day 4, fraction library materials, and I'm going to go to functions folder. And these are 2 of my custom functions that I've written for this workshop. And we are going to get NMR Box to upload these functions into our metabolomics toolbox that is already on NMR Box. We just haven't pushed those updates. We didn't want to do that before the workshop. But I have these functions here, and I'm going to highlight this whole path that's up here, including the front slash at the beginning. And I'm just going to right click and copy. And I'm going to put that path into line 4 here. We can just paste that here. Cool. And then the next thing we'll need to do is we need to give it the path to the processed folder, so that interp folder. So I'm going to go back into data, into fractions processed, and let's go to this interp folder, and I'm going to give it this path. Okay. Alrighty. So now we're ready to run this script just down the line here. And to run this script, I'm going to use this run section command here. And so I'm going to run each one of these sections one by one. So the first thing I'm going to do is activate the function. So we have our metabolomics toolbox. So if you want to do any of this analysis in NMR Box, we have our metabolomics toolbox where we have a lot of functionality. And I'm also going to tell it the custom functions that we just gave the path for. So I'm going to hit run section. Okay, and our metabolomics toolbox is loaded now. Okay. The next thing I'm going to do is import the data. So I'm going to first make the data directory my working directory. I'm going to use this function to load the data into MATLAB. And then I'm going to remove the 4 blanks that I usually use for every single fraction library to make sure that the data is good. I'm going to remove those for the visualization. Okay, and I'm going to hit run section. And you'll see in our workspace here that our variable is saved, and these are 140 spectra. Okay. Next, I'm going to put it into a matrix format and just visualize this spectra just overlapped on each other, not spread out. So if I run this section, we have the data that is in the matrix format, and this is this X variable here. And we also have a ppm vector that corresponds to the columns of this matrix format. So if I click on ppm, you'll see that each one of these columns, it represents a ppm value that is one of the points in the NMR data. Okay. And you can see on this live script that the figure that we just made is right here. If you want to look at a bigger thing of that figure, you can click on it and hit this little open in figure window. Let that load. Okay, and this is the superimposed data on each other. And so we can use this little toolbar up here to zoom in So let's like zoom in to all of it overlaid on each other. And so like this, and we can use this home button to go back out to the full view. Okay. The next thing that we'll do is I'm going to make a 3D plot so that we can visualize it like this. Okay. So in this 3D plot, the function that you'll need, this function has a few inputs. The first input is the data matrix that we just made, this X here, the ppm vector, and then a kind of like a range of ppm values that we're going to use. So if I open this up, I'm just going to run section again. We get this 3D image. It doesn't look 3D now, but you can use this rotate 3D here to start to visualize what's in the fraction library. And again, this fraction library's gradient isn't optimized the best, but it would be, you can do this even for not fractions. You can just do anything time series or something like that. Okay, and so to increase intensity, we can use this slider here to increase intensity that you want. Cool. And this function isn't in the toolbox yet because I'm still working on it. The select region capability is still in progress for like zooming in. So I wouldn't use that now. But to change the zoom, all we'd need to do is change these numbers here. So let's, instead of 5.1 to 7, let's make it from like 6 to 7 or something like that. And let's run it again. And now you can see the ppm range on the bottom here is changed. And again, these are the y-axis is the fractions here, and we have it kind of more zoomed in to where we want. Okay. All right. And then the final thing is, okay, how can we annotate these fractions? And so the way that I like to annotate is called Stocksy. And how Stocksy works is that it tries to, you input a driver peak. So say 1 ppm value, that's a peak. So let me open up this plot here again. And let me get a specific peak. So say that we're interested in, say, this peak right here, even though it's kind of hard to see. Let me show you how to get rid of a few fractions. So maybe we want only to visualize fractions 45 to 70. I'd have to go in here and I could change this X. I can put a parentheses here. I'm going to go, I want rows 45 to 70. And I want all the columns, and let me visualize this. Okay. So now we have just rows 45 to 70. Let me get the rotation. Okay. So we have it like this now. All right. So say we wanted to find out, what is this peak? What is this metabolite here that makes up this peak? So in NMR, one peak doesn't necessarily mean one metabolite. A metabolite will have several different peaks that make up an NMR spectrum. So Stocksy works by taking a driver peak and let's find out what other peaks are correlated with that peak. So what other peaks rise and fall at the same rate as that peak. And the way that we did this fractionation here is that this same peak is in multiple fractions. So we can find how this peak falls and rises and falls over those fractions. So that's what I did in this function down here, this Stocksy function. So that peak that we just showed was around 5.8 ppm. And I want to see how it rises and falls from fraction 49 to 56. And so let me run this. And you'll get this Stocksy image down here. Okay. And so let me explain this a little bit. So on the x-axis is chemical shift. The intensity that you see here is the covariance of the peaks to that driver peak. And the color is the correlation to that driver peak. So the thing that we're really interested in is what are the dark red peaks? And so those dark red peaks are going to be correlated with each other. So if we zoom in, these really dark red peaks right here are probably part of the same metabolite. And so we haven't, fully annotated this yet. So, we're not sure what this is. We can do several different approaches. We can take these, where the ppm locations of these red peaks and put it into a database to match, or we could do spike in of, a spike in of some standard after we database match to confirm, okay, these peaks are all part of that same molecule. So yeah, that was a lot of information. And so that was the kind of walking through how to process this data, how to visualize it, and how to do Stocksy.